Into talking about the mean value theorem, we first have to figure out Wednesday, because Wednesday is a very important day in here.
What is Wednesday?
Wednesday is my birthday.
He's turning 25.
Yeah.
You're able to retire now?
Yeah, because I'm 25. Yeah. All 25-year-olds can retire. All right. So we have to figure out, because I'll bring a birthday cake. But we are wondering what else we should add to the birthday cake. I am going to be 52. 5'2". All right. So, no. Okay. No. All right. Plates. There we go. We got plates. What? Juice? No. 5 points extra credit. All right, there we go. Okay. Mashed potatoes?
Yes. Say yes. Say yes. His mashed potatoes are good.
Mashed potatoes? We could do mashed potatoes, because remember, we have lunch. We're over lunch here. So DQ. Well, DQ is open. That's our first day they're open again. But we're not going to DQ. No.
We don't have to order DQ.
So let's discuss this more then after lunch. You can have, from now through lunch, think about it, and then we can get together and figure out what we're going to do on Wednesday. Now, for the mean value theorem. Okay. The mean value theorem is this. At some point, between A and B, the instantaneous velocity or instantaneous rate of change, and it could be velocity, but it doesn't have to be a velocity. The instantaneous rate of change is the same as the average rate of change. That's the mean value theorem. So it has some things that you have to know before you start. Now, the function must be continuous from the closed interval from A to B, and it must be differentiable from the open interval from A to B. Now, open interval, closed interval, you don't have to worry about that too much, but know that since this is an open interval, it cannot be the endpoint, what we're looking for. The C cannot be the endpoint. So don't try to use C as the endpoint. So the mean value theorem is this. Oh, just relax. We're getting there. F of B minus F of A over B minus A. This is the average rate of change. F of B minus F of A over B minus A will be equal to the first derivative at C, the instantaneous rate of change. So we have to find some C that'll match this average rate of change. We have to find the first derivative at some c that'll match this average rate of change. So let's take an example. Let's say we have a function f of x equals x cubed minus 6x squared plus 12x over the interval from 0 to 3. Okay? So what I would tell you to do first is find f of b and f of a. What do you think f of b is? Yep, so what is b here? 3. So you're finding f of 3. So you stick 3 into this function. 3 cubed is 27. 3 squared is 9. So 27 minus 54 plus, I forgot an x there. 27 minus 54 plus 36 gives you 9. What's f of a? That's f of 0, which gives you 0. So if you do f of b minus f of a over b minus a, it's 9 minus 0 over 3 minus 0, because this is a and this is b, equals the first derivative at c. So what's 9 over 3? 3. So 3 is equal to 3x squared minus 12x plus 12. Now we have to solve for x. So how do I solve for x? How about we subtract 3 from each side? We're not going to guess and check. We're going to solve. 3x squared minus 12x plus 9. How would I solve this? I'm going to do factoring, not the quadratic formula. X squared minus 4x plus 3. How does it factor? X and x, minus and minus, 3 and 1. So x equals 3 and x equals 1. All right. So the interval, the closed interval, was from 0 to 3. Now, is this function going to be continuous from 0 to 3? Not going to do anything super goofy. It's just going to go like this, right? Yeah, it's not going to do anything super goofy. Is it differentiable in that area? Yeah, all the curves will be just curves. It won't be like points. So it'll be differentiable. Differentiable from where? 0 to 3. Now, do either of these points not fit into either one of those? 3 doesn't fit into the second one. Because what do the parentheses mean? Can't equal that. So greater than 0, less than 3. So 3 doesn't work. So 1 is a place where the mean value theorem works. Okay? So what's the slope? Well, the slope is what? 3. So the slope is 3, so the first derivative at 1 is also 3. Okay, if we check that, 3 times 1 squared minus 12 times 1 plus 12 is 3 minus 12, which is negative 9, plus 12, which is a positive 3. So the average rate of change is equal to the instantaneous rate of change, which is the mean value theorem. All right, so where do we run into issues with the mean value theorem? Well, let's say I'm taking the function f of x equals 1 over x from negative 1 to 1. I'm going to have an issue with this. Because what are the two constraints? F must be both continuous and differentiable. So, if we look at this function, what does it look like? Yeah, it looks like and right? You should know that. That's something calculus students should just know, what this one looks like. So what is the problem with this with the mean value theorem? It's not continuous. So the mean value theorem does not apply to this. Okay, mean value theorem does not apply to this. So you will be asked in your homework if it applies or doesn't apply, if the person who is doing the problem, because they have like Anna says this, and then you have to read about what Anna did her problem about. And you have to say whether it applies or doesn't apply, or if they missed a step or didn't miss a step, and so on. Okay? All right, let's do another one. Let's do a function of a square root once. So f of x equals the square root of 2x plus 1 from 4 to 12, which includes 4 to 12. Okay. Now, is this continuous from 4 to 12? If you put in a 4, what are you going to get? 3. If you put in a 12, what are you going to get? 5. So from 3 to 5, if you know a square root function, they kind of go like this, right? So are they going to be continuous between here and here? Yeah. Okay. Is it going to be differentiable from there to there? Yes. Okay. So it'll be both continuous and differentiable, so it should work. So what do we have to do first? Well, we have to take f of 12, which we just said was 5, and f of 4, which we just said was 3, and go 5 minus 3 over 12 minus 4. What's 5 minus 3? 2. 12 minus 4? So we get 1/4. So then we have to set the first derivative of this equal to 1/4. What's the first derivative of that? Well, remember, taking derivatives, it is 1/2 times 2x plus 1 to the negative 1/2 times 2. Come on, Mr. Ricky, did you forget the chain rule? Well, what's 1/2 of 2? What's 1/2 of 2? 1, they cancel. So really, it's 1 over the square root of 2x plus 1 equals 1/4. See where I get that? The first derivative must be equal to the average rate of change. Okay? So if I cross multiply, 4 is equal to the square root of 2x plus 1. So if we square both sides, 16 equals 2x minus 1, 2x plus 1. 15 equals 2x. X equals 7.5. Is 7.5 within here? Yes. So at 7.5, the average rate of change would equal the instantaneous rate of change, which would prove the mean value theorem for this function. Okay? So that's what the mean value theorem is all about. Your answer is 7.5. Because at 7.5, it makes the instantaneous rate of change is 1/4, and the average rate of change is 1/4. Differentiable is that you can take a derivative of it. So let's take this function. F of x equals the absolute value of x from -2 to 2. What does the function look like from -2 to 2? Of v. Again, as a calculus student, you should know that absolute value functions make v's. Okay? It's my computer has an issue. It won't make straight lines at certain parts of my screen. Okay? So it makes it v. Okay? Is this function continuous? Yes. Is it differentiable? No, because it goes to a point right there. And if it goes to a point, it's not differentiable. Okay? Because the slope going towards that point is -1. The slope coming out of that point is a +1. So it has an instant change right there. And if it has an instant change, an instant change from negative to positive, you can't take the derivative of that. Why do you have to factor? Because we had to factor this problem because it's the second power. Okay.
Okay, I got. Okay.
All right. So mean value theorem. Before lunch, and you should hopefully get the 2 sets of problems done and watch as many videos as you can, because after lunch we'll take a little quiz over.
Oh, that was quick.
Yeah, there's only one section to the first section, and then there's a quiz. So yeah, that's it.